Hi, hello, welcome to our channel. In this video, I will discuss about Ohm's law. If you consider a conductor, the potential difference across the conductor is directly proportional to current passing through the conductor. If V is potential difference across that conductor, that is directly proportional to current passing through that conductor I at constant temperature. So Ohm's law states that the potential difference across the terminals of any conductor is directly proportional to current passing through that conductor. So V is directly proportional to I. So to remove this proportionality, we have to introduce a constant is R. So this R is called resistance. So V is equals to I into R. So resistance. So R is resistance of the conductor. So its units are ohms and it is denoted by ohm. So 1 ohm is equals to 1 volt by 1 ampere. Okay. 1 ohm is equals to 1 volt by 1 ampere. So with a numerical example, how V is directly proportional to I, let's see. If we know the relationship V is equals to I into R. Okay, V is equals to I into R. So from this we got V is equals to I into R. So where V is potential difference across the conductor, I is current flowing through the conductor, and R is resistance of this conductor. If current passing through that conductor I is equals to 0, then what is, and R is equals to 1 ohm, then what is V? V is equals to 0 into 1 ohm is equals to 0 volts. So if we consider a one conductor, the resistance of that conductor is constant, and when I is equals to 1 ampere, that means 1 ampere of current is flowing through the conductor, then the potential difference across that conductor is equals to 1 ampere into 1 ohm is equals to 1 volt. When current passing through that conductor is 2 amperes, then potential difference across that conductor is 2 into 1, which is equals to 2 volts. When I is equals to 3 amperes, then V is equals to 3 into 1, which is equals to 3 volts. When I is equals to 4 amperes, then V is equals to 4 into 1 is equals to 4 volts. So if you draw a graph between voltage and current, voltage on y-axis and current on y-axis, voltage on along the x-axis and current along the y-axis. So when current is 0, potential difference across the conductor is also 0. Okay, so when current is 0, potential difference is also 0. When current equals to 1, voltage difference, potential difference is also 1. When current equals to 0, when current equals to 2, potential difference is also 2. When I equals to 3, potential difference is also 3. When I is equals to 4, voltage V also 4. So if you join all these points, you will get a straight line passing through the origin. So These characteristics are called linear characteristics. Okay, linear characteristics. So this conductor is having linear characteristics. Okay, so this material we can say it is having linear graph. So this type of materials, the materials which are having linear characteristics only obeys Ohm's law. That means the materials which obeys Ohm's law are called ohmic materials. Okay, so based on Ohm's law, materials are classified into two types. So one type is ohmic materials and another one is non-ohmic materials. Non-ohmic materials. So ohmic materials means which obeys Ohm's law. Non-ohmic materials means which does not obey Ohm's law. So for these non-ohmic materials, examples are LEDs, and for ohmic materials are metal conductors. Metal conductors. Okay, coming to limitations. So Ohm's law is not applicable to non-linear elements. Okay, so the elements which are having linear characteristics are only obeys Ohm's law. And non-linear elements means, so those materials resistance changes with the temperature. So if temperature changes, current and voltage continuously changes. So for those non-linear elements, Ohm's law is not applicable. So Ohm's law is applicable only for metal conductors at constant temperature, and also other physical conditions maintained constant. And Ohm's law is not applicable to gaseous conductors, and it is also not applicable to semiconductors like germanium and silicon. So next topic is electric shock. Generally, our body offers a resistance of 100 ohms to 5 lakhs ohms. So if our body is wet with salt water, it offers a resistance of 100 ohms. And if our skin is very dry, then it offers around 5 lakhs ohms. Okay, so from 100 ohms to 5 lakhs ohms, our body offers resistance. So if you touch a 24 volts battery terminals, okay, 24 volts battery terminals with your two hands, by forming a closed loop, by forming a closed circuit, then current flowing in our body is, let our body offers a resistance of 1 lakh ohm. Then the current flowing through our body is 24 volts by 1 lakh ohm. Then current flowing in our body is 0.00024 amperes. So this is small amount of current. So this small amount of current will not affect the functioning of our organs. Whereas if you touch a live wire of 240 volts, then the current flowing through our body is 240 volts by 1 lakh ohm. Then current flowing in our body is 0.0024 amperes. So this amount of current is more compared to this current. So this current causes disturbance to the functioning of our organs. So this disturbance is called electric shock. Okay, so if this current further flows through our body, then resistance of our body decreases, and that increased current will damage the tissues. If that current flows further and reaches to 0.07 amperes, so it affects the functioning of heart. So 0.07 amperes of current will affect the functioning of heart. If that amount of current flows for a longer time, the person in electric shock is being killed. So here we are getting electric shock. Here we are experiencing electric shock. How means the potential difference between 2 points. Okay, so when we touch a live wire, of 240 volts, so what happens means, so this is our human body and this is 240 volts live wire, and we are standing on earth. Okay, so earth is at low potential level. Earth is at low potential level, and 240 volts live wire is at high potential level. So we are standing on earth. So when we touch a live wire of 240 volts, okay, so there is a large amount of potential difference between earth and 240 volts wire. So the current flows from higher potential level to lower potential level. So through our body offers less resistance. So current always passes through low resistance path. Okay, so current always chooses low resistance path. So we are standing on earth, so which is at zero potential level, and a live 240 volts live wire is at a high potential level. So when we touch that wire, then due to potential difference between earth and 240 volts wire, current flows from higher potential to lower potential. That means wire to earth through our body. So in our body, our skin offers high resistance than the other organs. Okay, so skin offers high resistance and other parts of body offers less resistance than skin. So that we can say, so the resistance in human body is non-uniform. Okay, thank you.